Yeah. Okay. This is yeah, he dropped off now. Okay. This is Coffee Compiler Club. Anything to do with compilers and language runtimes and garbage collection and concurrency and typing and multi-threading and security and safety and language implementations of all kinds. It's an open mic. Ask anything you like. I reserve the right to moderate. Never had to do it. You're being recorded live. This is your permission to be recorded live. The video shows up on Twitter within a couple days. No set agenda. That's it. I'm done with the spiel. I've been pushing on AA and have had an unrelated real life intervention event happen. And so I've been doing real life things, and we'll probably be doing real life things for the rest of today. And maybe I'll get some coding done and maybe I won't. And next week I'm going to go to Philly and see my grandchild. So we'll see how progress goes. And I got more interested folks looking at the typing going on the academic side. They're downloading and running it now, and he's trying to write tests and see if he can type. So, but he's in New Zealand time zone, so it's like we get to go back and forth once a day for a little while, and then we're on the wrong zone. So the usual story. That's all my status updates. Real life intervened, and I didn't get anywhere. Hey, Marino made it. So Marino, can you hear me? Say something. You have no audio symbol. You have no mic. You can't tell. I can't tell if you can hear me. You can't tell if you can hear me. All I want to tell you is you're being recorded, Marino. I'm going to put it into chat. Maybe you can read that. There you go. You have a mic symbol. You're being recorded. If you don't like it, bail out and watch it on Twitter. That's it. That's my warning to you. Okay. Anyone want to do something here or go? I got Cameron threw out a fun read, which is actually a legit question. It's lifetime management of closures.
That was a good read.
Yeah, it was a good read. Yeah.
Can you retro the link? I do not see it.
Oh, that's interesting. Okay. Yeah, I threw it in chat. I figured everyone could read chat, but probably if you join afterwards, you don't get it. Let me make sure.
That's a privacy rule. You don't get to see any chats before you joined.
Oh.
I just see the Cameron's lunch.
There you go. Yeah. So the short gist of it is, if you have lambdas and they have their standard functional style functions with no real lambda going on, you can use a stack. And if you go up scope, you can get to prior generations that have to live until the originating, like if you reference variables higher in the stack, that might live until, even if the function you're in question would otherwise disappear, but it's been passed off as a function pointer and being handed around, and you could still do a stack thing independently of concurrency and multi-threading. That's a separate issue. And then if you do one, if you escape the local closure, you can't use a stack paradigm, and you need to have something else. And Objective-C folks are saying, we're doing reference counting, and the standard, ML Haskell style folks say garbage collection. And then there's no guarantee of lifetime, and C folks are all like, lifetime management, please. So when can you do lifetime? So then there's GCC blocks, and there's nested functions. A bunch of people have tried a bunch of things, and story comes around to there's no hard and good way to guarantee that you can control the lifetime management if you're a C person and you're used to controlling it with any of the existing C lambda-like behaviors. So there's another proposal, it's the XKCD. There's 14 proposals. Wouldn't it be great if we had one that covered them all? Well, now there's 15 standards. Okay, fine. So there's a fifth standard proposal out that says we're going to make function pointers or lambdas where you malloc yourself the closure. You have to list the escaping variables that are going into that closure. And then because you did a malloc, you can do your own free as well. And if you wanted to do a conservative collector, if you wanted to do anything else, there's other ways to manage it. But as soon as I allow you to malloc and free, you have ultimate control, and you can ultimately shoot your own foot, and everyone's all happy. So that was the fun read. It was a fun read because the guy goes down the lines of, and GCC did this. And in order to make this work, they had to turn off the no execute bit. And immediately every security person on the planet screamed at them and said, you God, no. And, some set of people love it and it works great and they just turn off security and they don't care. And some set of people hate it and have hard enforced rules where if you ever touch this version of GCC, thou shalt never be allowed to execute ever again. It was a fun read.
So the core of the problem is that when the lambdas capture variables, that it's become hard.
Yeah, what's the lifetime if you escape a function pointer or the lambdas captured a variable? Yeah. And I have the same problem, and I would coming down the path that was being done half by GCC or Clang, which was to say, if I can infer the lifetime is stack-like, I'll just be stack-like. And if I cannot, I'll promote, but there's a cost model there. I'll promote it to GC, or I'll demand Rust, like behaviors.
Wasn't that one of the safeties you wanted for AA, was declare something as this does not escape this frame?
Yeah, right. But suppose it's going to escape. So there's two separate things. There's management at the language level of saying, I want to help from the compiler that says nothing's escaping, it's stack allocated, we know, it's happy and fast and lifetime managed.
So there are two issues though. So we should split them before you go too far, because there's the one issue, which is the capture. Where does the capture go to form an address you can call that has the capture, right?
Right.
So the old trampoline approach was to do it on the stack, to actually build a new function on the stack. And that's where the NX bit disallows it, right?
Yeah, right.
So basically you either have to, DB, set aside some block of memory globally for some fixed number, 1, 2, whatever, of trampolines, or you have to allocate it dynamically. So there's that. And then the other, so it's kind of like there's a, where do you put it versus the capturing aspect of it? Because if it's stateless, then it's already easy to handle. It's just a function pointer.
Yeah, it's not the stateless ones that I'm worried about.
I mean, it kind of makes sense to have two heaps and be like, this is the not executable heap and this is the executable heap. And
no, you don't.
When you define a new function at runtime, it goes on the executable heap.
You don't need a trampoline on the stack. They were doing that so they could do lifetime management games. The way I'm headed down this path is I'm going to have, I won't say fat pointer, but an alternative pointer that I know is functional, and it's actually the storage, wherever the storage came from, and the first element of the storage is the function pointer itself I'm going to call, and the rest of it's the closure. But now I have a thing executing on the stack, which has this other lifetime closure that's also being dealt with. So you have to have, multiple different ways to deal. Like you can't reference it from the stack pointer because it's not on the stack. So now at that point, I kind of want to say there's a cost model problem. I don't want you to be guessing at the cost model. So therefore, there's
so if I have a big thing on the stack and I close over the big thing on the stack, and then I return, at what point do I copy all the big thing to the heap?
Well, statically, I'll know that you're going to close over.
How about a stack of captured variables?
So I want to claim that when you wrote the function that escapes or may escape a large thing on a stack, you got at that time a compiler error that you can remove by saying, and please go ahead and escape this closure. So this particular stack frame, all the references will be via another pointer, not the stack pointer. And
so if it escapes, it makes sense to say, go ahead and allocate it on the heap. And if it doesn't escape, it makes sense to say, go ahead and allocate it on the stack. What I want to know is, what if it escapes 1 in a billion times?
Right. So then you have to decide that you want that as your cost model. And I did this with stack-based allocation. You paid the escape cost at the time you did it. And the usual story was things escaped when you threw an exception. And if you never had an exceptional condition, it never escaped. And that was common. But it required a bunch of infrastructure, and it gave you this funny cost model, right? The funny cost model was, it was all stack allocated and fast until somebody blew an exception. the exception paid, but once he paid, he made the heap copy of shit. And then references to those objects got escaped. And suddenly your cost got more expensive. Sort of in perpetuity, but usually you unwound everything, everything died on the heap a little while later. But you could arrange a version of code where it ran fast until the first escape. Thereafter, it ran less fast. And that's a funny cost model. So I'm not happy with that one.
There are languages that they have keywords that do not permit variables to be captured at all, just plain lambdas, and that's it. Yeah.
Right. So
more aware of the cost.
Right. So, but my theory is you'll have to throw down a keyword that says, and here I'm aware that cost gets weird. Right. Like there's some syntactic sugar that's the default that says, I don't care, best effort, yada, yada. Exactly what you're saying there, Aaron. It'll be right up until it escapes, and then it'll be a little worse, and I don't care.
So the interesting thing with that, the spec that they're suggesting for the new C standard is that the captures have to be explicit. So you basically, before the argument list, you have to say it's going to capture these these names that are currently in scope.
Yeah, I think that's C's problem. I'm not going there.
That's a pretty tedious, I believe. It's tedious to write all the.
Oh yeah, it's tedious, but it's kind of following that same thought train though of being quite explicit.
Yeah.
From the cost model point of view, I think that's actually good. And I've been using lambdas since C++11, and I have never ever found it a problem that this is too explicit. In fact, if you are reading someone else's code, this is a strong advantage that you have to list those captures. And if you have nested sequence of lambdas, you want them to be explicit.
Interesting.
I think it would probably
more or less.
I think it would matter there. I would imagine in languages like C and C+, the use of lambdas is a little less common than in high-level languages, or higher-level languages. Let's say this, because they're not super common in Rust, for example, but they are used in various places. Most notably when you use their iterators for mapping and filtering things and such. And I think in those cases, if you have to use it often, having to list, especially the same variables, either in nested closures or just separate ones in the same scope, it gets kind of tedious. But I think in a language like C, where the use case, I guess, is different.
The use case
I mean, I
is
think that
similar.
fits the C++ paradigm nicely to be like, yeah, we're going to make you say what you want. Because
the use case is similar, but one important point, there are shortcuts. You can write equal sign, which means capture every used variable by value, or you can write ampersand side, which means capture every used variable in this body by reference. And so that's one character. And then you have behavior like in high-level languages.
Yeah, I was thinking if you had a shortcut, that would work.
It's just one character to type. I really don't find it onerous.
Right. But if you wanted to list them, you could.
I think there, at least in Rust, the thing that helps it there is that by default, captures are moved into the closure. So you don't really have the problem where you capture something gigantic that you may actually also want to keep using, because then you get this question of where
when you
do
say
moved into the closure.
Yeah, what do you mean?
So let's say I have a string. Let's say a array of, I don't know, 1 gigabyte of data. If I capture that by reference, the Rust compiler ensures that I believe the closure cannot outlive the reference. And similarly, when I drop that closure, the list just stays around. If I move it into the closure, dropping the closure also drops the list. So it's kind of similar to
back up.
It's kind of like as if it's created inside the closure, but only on the first time you call it.
You said move into the closure again while defining what move into the closure means. Let me try again here. So there is a closure that's separately a thing that you mention as a first-class citizen, not as a...
Yeah, so let's say a simple example.
Like in a
Go
trivial.
with dynamic array maybe. If you think about dynamic array implementation, let's say you implemented this as a class, okay? And inside this class, you have a pointer to data, and data itself could be 1 billion elements on the heap. With me so far? So moving means you only do pointer reassignment. It means steal the guts of this container. So it's very easy to see if you have value-oriented language because it actually stays as a value. It may be hard to see the distinction if you have reference-oriented language, but you can basically have this object of a class that inside has a pointer, and this pointer points to data on the heap. And the point is that data on the heap is never copied because you only ever steal the pointer as you pass this along. So it's a little bit like reference semantic, but implemented as a value. And the value that is being copied is just a handle to a remote data that only exists once.
It'll cost you an allocation, though.
Yeah, somebody's managing the just exists once.
So in Rust, basically, when you, I mean, a reference I think is fairly obvious, but when you move, usually it's just a mem CPI that it uses to, I think, just copy the pointer. So in other words, if I allocate 10 gigs, assign it to a variable, capture it in a closure, but then I capture it by value, there's no actual copy of that 10 gigs. It's just allocated once, and the closure is in charge of deallocating it when the closure is deallocated.
So this is Rust doing lifetime tracking. And
yeah.
Declare the
and it can do that because of its type system.
Yeah.
And it has some clever things there as to.
But it's the like whole mutable, borrowed, owner-owned, whatever thing going on. Yeah, I get it. Yeah. But that makes sense. No, I knew that piece. It was if you did anything by value on a giant. There are two questions. One was you did anything by value on a giant thing, then you had to make a giant copy, unless you're doing cow. That just delays the giant copy. So R's problem was getting giant copies made behind your back. And the other one is the lifetime, which Rust has a way to manage the lifetime. So as soon as there's a single owner, there's never a copy made. You just carry the pointers around and track it that way. Yeah.
And in C++, that's the move semantics. You can also force the type to be move only, which means you can never copy this by accident. But if you have a choice and you are in a new programming language, I would do what Rust does, especially the destructive move. This is much simpler than having the management on C++. So.
Yeah. Well, the other question I had was, you kept saying closure. What's a closure to Rust? Is it a thing that I do an allocate and a free on, a malloc and free, or is it just another stack frame that's running that has a normal stack frame like thing? I didn't do anything special for allocation management for the closure, or I did. That's what I'm asking.
Closures, if I have this correctly, I believe by default they go on the stack because they're essentially desugared into just a structure.
Yeah.
And that structure by default, I believe, goes on the heap.
Stack or heap?
Sorry, the stack. Yeah.
Okay.
Yeah, small difference.
Yeah.
If you want to put it on the heap, you have to explicitly use a type called box to.
But you can do one on your own stack frame, or somehow you can declare a stack frame to be boxed because I want it to go in the heap because I'm about to escape its lifetime.
I don't like. You can't really explicitly do anything of like actual stack frames. Like the way this works normally, let's say syntax wise, a closure spacing, x equals pipe, and then parentheses to have the body, for example. Okay. That's a closure.
Horrible syntax.
Yeah. Fine.
Yeah, I mean, I'm used to it from Ruby. Yeah, pipes I'm not a huge fan of. If you then say pass that closure as an argument, it's still on the stack. Like you just move it over. Rust generally with these things doesn't implicitly stuff things on the heap, unless it's like a factor, a string, or these sort of collection.
Yeah, no, but keep going. What happens if I escape lifetime here? Somebody has to declare.
So if you have a closure, for example, that let's say it captures a reference and then the closure is returned,
Yeah.
I believe Rust will produce a compiler error.
Okay.
And so if you want to be able to return a closure, it must move things into itself. There's syntax for that. So instead of pipe thing, it's
Okay.
move
So,
space pipe.
okay.
And then you can, I think you still cannot capture references on the stack because the stack goes away,
Right.
but at least that stack frame. But you can, in that case, capture moved, owned variables.
You can capture owned variables and then you own them, right? You
Yeah.
take the ownership away. Okay, fine. Right. That's what I was asking was somewhere in there you've declared the lifetime of the closure is no longer stackish, which is what the C guys are trying to argue for. Don't automatically declare lifetime behind your back because you can't control the lifetime close enough.
Yeah, can Rust declare something like a lifetime? Let's say it's if it's an HTTP request response, when the request returns, everything is deallocated at once. Can you say that in Rust? Everything that was allocated right now for this request goes deallocated at once.
I mean, there's no way to encapsulate that in the type system, but what you basically do is pass those values back up essentially to the code that sort of started the request, and then that will just discard it, and then the drops are inserted essentially where that value goes out of scope.
I thought when you
So-
nude stuff, you could explicitly say, no, I want this to be this scope lifetime.
Sort of. The confusing thing there is that the lifetimes in Rust, they're not necessarily tied to the, let's say, the memory lifetime. As in, if I typically when you have like a function, let's say that takes two references, or perhaps it takes a reference, say a pointer, like some sort of object, and it wants to return a reference from something inside of that. That's a typical case where you might have to explicitly annotate lifetimes on these references that you take and return. But that's basically a way of saying, hey, this reference that I return will live at least as long as this one reference that I take as an argument. It doesn't really say much necessarily about when that is dropped, because that's based on when it goes out of scope.
Yeah, so it can be convenient to say either I have a web request or I have a game frame. And then I just, all of the work that I'm doing for the game frame and all the work that I'm doing for the web request, I put as a tagged lifetime. Oh, it goes with the request or it goes with the frame. And then when the frame paint ends, throw it all away.
Exactly.
Right, so that you can't do in Rust, but that's basically an arena. And there are some libraries that let you do that. Rust support for this is a little finicky because a lot of the collection types, they implicitly use the global allocator. So you can't easily override that to use, say, an arena allocator. They're changing that incrementally. So I think with the vector type, you can now specify the allocator to use. And so you could use your own arena. You allocate the arena at the start of your request. Everything goes in there, and at the end you're done. But this isn't something you can natively do. The closest is there's a lifetime called static.
Basically, arena is its own allocator. Give me that much of bytes, and I will deal with them. Is this roughly?
The usual story with an arena is there's a bulk free at the end, but it's like garbage collection where you only walk the live, but nothing's live, so the walk is free and it's all done at the end.
Yeah, you bump the pointer back to 0 and we start again.
Yeah, right.
Yeah.
And I'd love to have compiler support that tracked the lifetimes to know that it was legal. Same token, the compiler could issue the code to do that for you under the hood.
You have to ask the arena how much you want specifically. It cannot calculate it for you from the types you use.
Sure, dynamically.
I think generally, I think it should be possible because I mean, at the end of the day, how you allocate doesn't matter, right? It can be a list of pointers that you just randomly allocate all over the place. It's just a way of saying, all these things I've allocated that belong to this arena, we get rid of them over here all at once. But how you allocate them doesn't necessarily matter.
Certainly when I was playing these games in times past, the arena had it was essentially a lame ass GC with T-labs, slab allocator. Would bump pointer allocate in one thread. When I ran out, I grabbed some more and added on the end of my linked list and kept bump pointer allocating. But when I got to the end, I walked down the big chunks and did a free on them all, and you were done. And then the actual after that was actually a little smarter. I knew I was going to reallocate again, and I went back and forth left and right. So I would just reset all my chunks and didn't throw the end guy off unless it wasn't used after the last back and forth.
How did you do the generation counter so that if someone tried to carry a pointer from the previous generation to the next one, it would blow up?
Didn't. That was C code for a hotspot C2. If you screwed that, you screwed that.
So your solution there was not a generation counter, but it just don't do that.
Yeah. I'm not claiming it's a good solution. I mean, it's fast. It was efficient. We lived it for
It works,
25
but it
years.
Requires faith in your fellow developer,
It does.
including yourself at 3 a.m.
So does an arena. Arenas always have the same problem. So I'm looking at Rust saying, I will type safe your arena. I'll malloc lifetime safe your arena. People have been using arenas for 40 years. And they, by and large, it's doable because by and large, I have a lifetime it ends. Okay, it's done. But then they track the bugs where they failed to get it right and they screwed the lifetime. That's the whole malloc free bug problem. Same problem I lived with when I did C2.
I'm not absolutely sure, but Rust is, and I may be wrong, of course. The Rust is not absolutely good. It's absolutely good tracking one object at a time. What its lifetime? Is it on it? Is it not? But it doesn't. His strong game to track a multiple object at once, to be deallocated at once.
Basically,
it doesn't.
Right.
Yeah.
Basically, I have one pointer into the start of a compiler IR, which is a giant, horrible mess that gets hacked a lot. And then I did a giant copy from this version of the IR to a new version doing a transformation on the way. And when I'm done, the old version had one pointer into it, but I deleted, and that whole set is dead. Now I want somebody to magically delete the entire old IR version without actually walking it and teasing it apart and breaking it. So I just whack the arena. In my use case, it was easy to manage lifetimes, right? And much more efficient just to whack it. Can Rust manage the lifetime and tell me that I got it right? I don't know. That's a tricky one.
So for arenas, there's no built-in support. I don't think the type system has a capability for this either. There are some third-party libraries, and what they usually do is when you create the arena, that's sort of an owned value, and when you drop that, it drops its values. And then I think the things handed out are like actual pointers. As far as I remember, there's usually some caveats like, it's sort of arenas, but and that's the thing, like you have the choice, you can get pointers, but then you are in charge of making sure those pointers don't outlive the arena. Or you get some sort of handle that when dereferencing will check, hey, is this arena still there?
Yeah, I was looking for no runtime overhead. I just wanted to whack it. No.
Can each thread has its own arena, so it basically doesn't track is it there, is it not, and just bump its pointer back to 0, and there we go.
I
think that's green threads, isn't it?
Say again?
Yeah, something like that.
I'm sorry, Aaron, say again? I didn't hear.
I said, I think that is green threads. I'm essentially going to allocate a little stack for this thing to do its own job. And when it's done, the whole thing goes away.
Yeah, but it doesn't like it. It is like green threads in this sense, but it's not like green threads because you spawn them continuously. I say you get one arena per physical thread, and that's it, or logical thread. Okay, let's if you have 16 threads, we have 16 arena, 1 megabytes each, and that's it. And we bump the pointer at each request, at each frame, at each something that we tell it to the lifetime is over, and we start new generation of garbage.
And any communication between threads has to go on the heap?
Yeah, I'm missing what the issue is. You got independent threads, they got independent T-labs, they had independent bump pointer allocators, it's all fine. As soon as they want to share, they have the usual sharing problem. It has nothing to do with arenas.
Oh,
You run
okay,
C2 on a JVM, he's going to launch a bunch of compiler threads, especially at startup. They're all going to grab their own heaps. They're all going to do their own thing. And do they share? Yeah, in the end, they turn around and say, a lot of code. I want to install it in a shared place. So I have to do lifetime management of a produced object at the end, which is actually a very complicated mess of other objects. Yeah. But then while that thread's running, he's all free and clear as a standalone, unrelated to anybody.
The problem is when you want to share data with the rest of the system. Okay.
That's the normal multi-threaded sharing. It's nothing to do with
arenas. Yes.
It's easy to screw up with arenas because you get used to throwing everything in my arena. I'm done with it now, I'll whack it. But no, you handed off a pointer in the middle of your arena and you whacked it. Now the other guy's got a pointer into your dead arena, which you reuse, and he gets screwed up. So it's easy to screw up here. This is where
you're in GC land and their one pointer keeps your entire arena alive.
Yeah, right. Or your GC land, or you don't have Rust, so you have to hand manage or whatever. Yeah, right. This is what Rust is good for in that sense. What is the right thing? Pony. You declared it as a multi-threaded published value. Okay, so it had to get moved out of whatever cheap ass thing you're doing and moved into something else. I think I have the Pony link up.
How does all of this interact with, say, loading new code at runtime? Which also seems like you would be pulling in a whole bunch of stuff.
Oh.
I mean, loading new code at runtime? Certainly I can step you through all glory detail there. What do you want to know?
So particularly you started with the you have the no execute bit. You have to pull in new stuff and keep the things that can be executed separate from.
Yeah, no execute's on the stack.
Yeah, it says the NX bit is a stack protection to avoid generating code on the stack itself.
Right. It was a stack overrun, fill the buffer with, jump to my evil hack I've stored somewhere else, overrun your stack and see if I can't get you to execute this giant buffer I put on the stack that just says jump to me and I'm in control now. Fine. Yeah. I hit the admit button. Try again. Yeah, I got Charlie showing up here too. Yeah, the add code at runtime is you need a magic class for name, which basically says take a wad of bytes and turn it into a wad of code, however that's done. And now I have a function pointer that I got out of the class for name that I can call and begin executing.
But that feels like a very different process in, say, the JVM versus Ecstasy. That's like,
no.
Can't you force yourself to have to recompile a lot when you dynamically loaded a new class?
Stop. So you have to back up here. So you're going to implementation. So there's there's a way to skin the cat, and there's a billion ways to skin the cat. There is the high level conceptual problem. Somebody told me I have a pile of bytes. Magically from this, I get something to execute. As soon as I execute, I have all these security problems because I took the execution from a pile of bytes. So there is a careful security managed translation from wad of bytes I got over the internet to something I'm going to execute safely in my sandbox. Now, once I've crossed that security threshold, the thing I execute, I can make go faster or not according to, I'm interpreting Java bytecodes, I am jitting code cheaply, I'm jitting code expensively, I'm doing whatever. There's a speed, but there is a mental security step you have to first cover, which Java claims is the verifier, and XDC has, I'm sure, something similar.
And that verifier can be as light as I read the bytes and decide that they're fine, or as heavy as you gave me a bunch of JavaScript that I actually have to compile.
Yeah, and JavaScript does the verification incrementally as he executes new stuff. But yeah, suppose I decide to do an eval for AA and I have a wad of shit I'm handed. I'll actually, at the string boundary for the eval, I'll parse it all and type it all. That's my security check. Now, what you get back is a thunk, and however I execute the thunk, I execute the thunk. That would be my boundary. JavaScript is incremental to hell and gone.
I'm sorry, what's a thunk?
A function with no
function zero.
With
function
no
0.
arguments and no closures.
Ah, I see.
Has no external state. It just is a thing you can now execute. Maybe it has access to any of your internal state, like an eval looks up variables in your scope, but a safe eval execution would say, what you pass me. So the thunk actually is not, take some arguments maybe, because I've declared it, my string is going to require some args, so on the function
it's
declared.
I mean, I would argue I
executed
want some kind of environment passing where I can say, great, here's your thing. You can
Yes,
printf.
and that's where all security holes come from. So there's where you have to very carefully delineate the default from I'm willing to open the door to I'm very worried, so the door is shut tight as I can get it with a little tiny keyhole to leak a little bit through. To, you know,
Right. If I import the trigonometry library, I probably don't need to give it file system access.
as soon as you say I'm importing a library, then this is the JavaScript model. Then there's all kind of security holes because what library did you import? Well, I went to Maven and grabbed a library dynamically. What was the library called? It was called trig library.nigerianprints.na.whatever. And you know, oh, it's a trig library. No, it wasn't a trig library. It was, you know, security hole to hell. So, you know, class for name that then goes and gets more class for name and recursively gets more class for name is where you need to have the security that recursively carries through. As soon as you open that door once, you're recursively opening that door, and then how far does it go?
The most generic library I have seen is that from Google, libseccomp, to filter system calls of the binary you don't need, actually. I will throw a link. You can filter system calls at the binary level, which one is allowed to do and which one is not.
I was thinking more of Cameron's example of loading Apache comments and getting a 0-day hack.
Yeah. This is about loading code in your language from your language. This is more like of a binary thing to filter which system calls you allow to
Oh,
make.
I
and which
see.
But I feel like if I'm building a large distributed system, I really want the ability to like pull in some new functionality.
Yeah, right. And so you want to have a verifier that then recursively allows you to go. And, but like all security is built in layers because everybody has, you know, holes. So you just need to have a way to manage sort of as fine grained as you can tolerate how far you're going to let something go through.
My opinion is to have to move from the bytes model approach. You have to have some way to embed more structure in the code.
Well, that's the
loading
job of verifier says these bytes are actually a class file and they have high level typings that I'm going to confirm and validate and shit like that.
Yeah, that qualifies for this, yes.
But this goes for everybody. You start only with bytes over the wire. You're coming from an untrusted source. What do you get? You get a pile of bytes. That's all you're going to get is a pile of bytes. Now, up level the pile of bytes. Well, internally, the pile of bytes has to be structured in a way that you can.
Yes. Yeah.
Okay.
At this point, they become code, and from there,
from there you can execute, right? And if they in turn say class for name and go grab more bytes, then you know you want to let them. They can't get more security by loading more bytes than they already got by executing in the first place.
That's a good measure.
So you have to transitively keep the security box going.
It seems like at that point, you're most of the way toward building a macro system of
not a macro.
Build me up a block of code and then let me manipulate that structure and then run the validator on that structure and then pull it in as
I'm already there. Well, that's what a val does. Here's a string. It's a pile of bytes.
Right, but eval tends to just be like, I am going to take my string and I'm going to evaluate it. I kind of want to split it into like, this is read, which turns my string into a structure that I can manipulate in a programmatic way, and then some kind of evaluate the structure.
So two different things. So I say eval, what eval is going to do is type check you, and if you're type checked, hand you back a function pointer. Right, and if you don't get a function pointer, you get an error back, fine. Okay, so you got a function pointer, you can execute it. Now you're saying, I want compiler IR.
Yeah, I kind of want to do it in two steps: string to structure, and then structure to function.
The problem is as soon as I hand you back a compiler IR, I have frozen what my compiler IR looks like for all time. Because as soon as I change my compiler IR, your hacking on it is like busted. So Java said, I'm going to do it in 2 steps. One step is Java, one step is bytecodes. And that's your compiler or intermediate representation is bytecodes.
Yeah, as soon as you fix your IR, it's become your ABI basically.
Yeah, exactly. Which I'm not willing to go do. I've seen people do that, and I'm not willing to go there. So if you want to hack the hack things at some point, and what Theodore just said was it becomes your ABI. You have that's your point of where you do security checking. It's not translating strings to IR. It's if I'm eating IR, the IR is my bytecodes, and that's my security. That's where I verify. So at that point, why don't you just hack the string? Why are you hacking the IR? What was the benefit? Why don't you build an IR yourself that you hacked personally in your own thing, and then you hand me a string back? You print it to a string and hand me a string back.
An interesting exploration is a typed abstract syntax tree, like for the Scala tree example. It's an interesting experiment.
Yeah, types move slower, and because it's a whole language. So I could imagine handing you back a typed version of things that wasn't anything to do with any executable formatting at all. But
that basically, oh, sorry.
Yeah, but that would be a point where it would be, there's an obvious trivial pretty printing of that structure as a string.
Yeah, but this still doesn't go all the way for flexibility with this typed abstract syntax tree. And you have to have basically something halfly baked in between, not abstract syntax tree, not exactly strings. And that is basically the side project Scala.js have its own intermediate representation, which is translated one at a time. And this is basically how they do code evolution. They interpreted this halfly baked abstract syntax tree into something newer. This allows them to keep compatibility.
Wow. Yeah, I didn't want to go there. I'm all happy to, read your string and produce something that's useful for you to look at, but I make no promises that I'll inhale that, because that's going to vary by whatever the backend does.
And from the other project, the other problem is that basically this IR is too low level, and your language is too high level, and when it's translated from high level to low level, it's a lossy compression. You cannot go back, and you have to maintain.
I mean, you could, or you could have that IR be literally one-to-one correspondent with the syntax.
Yeah, and that's
right. And it is the language. It's just the language in maps and lists rather than the language in a string.
That is what basically Scala tasty is. It's a IR, which is basically AST, but it's some more binary representation, let's say.
Well, AST is binary already.
The AST is represented, each keyword of the AST is represented with each number representation, and basically that's what you serialize, because Scala has more structure than Java and have to have more features in there, precisely because when translated from high level language to a lower level language, which is basically bytecode for Scala, there are some features that are lost and cannot be recovered again.
Bytecodes. Yeah, bytecodes is a lossy format very clearly.
Yes.
Yeah, I could imagine producing an AST, but I don't want to inhale it, but I would let you pretty print your AST and give me a string again. Like the translation step from a string to an AST is going to be super cheap if I don't bother to do any type checking. Like the parser for AA is actually really small, and it would be just really fast to produce an AST.
Why not?
But I'm not
in between. You serialize the AST type checked. And becomes tasty. Type.
Yeah, I get it. Right. So then if I type check it and also have an AST, which I wouldn't have because that's not how I do things. I definitely still wouldn't want to inhale that as an alternative parser. You're asking for an alternative parser. And why are you doing this? Because you want to walk an imagined AST because you're trying to manipulate it in some interesting way. And I'm trying to figure out what your goal here is. So maybe a goal is I want to have like a language server for IntelliJ Who
They're
wants to say
basically
I want to do
macros.
refactoring and shit like that, right?
Macros operates on the type at abstract syntax tree.
Oh,
syntax
right.
tree.
Yeah, I was doing my macros a different way, right?
How are you doing your macros?
Well, with type safe if tests that take in code. Don't do macros, just do if tests.
Regarding macros, one thing that's always been a little unclear as to how you implement this with hygienic macros. How do you handle, assuming you apply them at the AST level, how do you ensure that the variables defined inside are not colliding with those on the outside? Like,
Well,
classic case, I do number is 42 and then, some random macro and it does number is 50.
well, you do a capture free renaming, which
Right, so you do actually traverse all the
no,
identifiers and rename
I'm not
them,
implementing this
essentially.
in my language, but
No, in general, I mean.
yeah. Well, no, any capture free renaming, and there's a couple ways to do that. One of them is you pick a unique name for all your variables. That's the unique name that's under the hood. Like the macro said whatever, but you immediately renamed it as you expanded it into. You malloc a new internal variable structure from whatever your compiler does. I don't know what the hell your compiler's doing there, right? You can imagine just getting a UUID for the variable name.
All right, yeah, because I always thought it was something like that where you either generate a name or perhaps traverse the AST and rename it, but there's no like clear thing like yes we do this or no we don't. So
okay.
it's like
so if you're looking for sort of the way that you want to do it in a way that's the most polite to the end user is that you internally you generate a name, but then you go backwards and look and see if you can use the name that you were given without having any collisions. And there's tricks you can play there to go mostly get away with using the names that the user gave you. Maybe you add an underscore number to say, oh, but I collided, so I'm now, foobar under 1. And then the macro got used recursively, repeatedly, many times, and you get foobar under 1, under 1, under 1, under 1, right? And it gets uglier and uglier and uglier. So I've seen people go both ways there.
There has been a pretty good talk and paper about it at Hopple, and in fact, this algorithm that Cliff just described, introducing unique identifiers, that's called Belger 1986 algorithm discussed in this talk. This talk is especially good because it talks about the caveats in implementation. There are ways you can really screw this up when you revisit the syntax tree again, which blows up the complexity algorithm of the algorithm to quadratic or even exponential. So it's a good talk because it's not just theory, but actually talks about those things not to do. So highly, highly recommended.
Cool. I will check it out.
Yeah,
ultimately it's just
nice,
function scoping, right?
Yeah, it has all the, it's from Juan too. Klinger and Juan, okay.
I was gonna say that because the usual advice with this stuff like, oh, you just look at the source code of Racket or something. In other words, just look at these 40,000 lines of code and you'll understand. You're like,
yeah,
thanks.
Exactly. Yeah. Okay. So here's a paper. Yeah. Okay. I'll look at it later. Yep. Yeah.
It did surprise me though how easy it is to screw it up, because it sounded that the talk is kind of funny in a sense because it introduces the algorithm as something simple, just do timestamping, just add number to each time you introduce an identifier. But in that, if you do that, that's actually this naive approach that explodes. So it's kind of fun to watch the progression.
Mm-hmm. I lived through some of these. I not a huge amount. I backed away from them. I used hygienic macros in, I want to say, Scheme or something related for a while, who then went through a couple rounds of bug fixing when they didn't get it right. And then it was just like, it was like inlining in C code. You could hard guarantee functions got inline, but what was the other use for it? In C, the other one you got out of that was, what is a compile time constant? You could force with a macro a compile time constant because the expression would be exploded completely in line. You knew the compiler was going to fold it up to a constant. Whereas if you had function calls in there, you couldn't force them to inline it to a compile time constant. And I think C++ maybe got this more right now. I wanted to know ahead of time, this is going to boil down to a constant before I went on to the next step. Like I'm going to allocate an array of size X, and X is a very complicated expression, but I needed to pre-allocate at the start of the program because it was going to be in a little fucking embedded device and there was no allocation, no malloc, it was all going to be pre-allocated everything. What was the guaranteed way to force the guy? Const expert. Yes, that's what I'm looking for. Thank you. Thanks, Cameron. Yeah, what is the rules for const expert? Macros is one way to not have to deal with the rule. Or the lack of a rule until const expert shows up. Silence.
I'm happy to not have to deal with macros though.
Excellent. Yeah, me too. I don't want to deal with macros.
They were necessary in C. They made sense with C, but
Right.
You're just upset with the C version of macros, I believe.
So if I don't have something like macros, how do I write match in the libraries? Or does that have to be a language feature?
What's match?
Match
I
is a
have
language feature.
something. It's one of these 6 structures. Hold on, let me find out.
It has no.
A switch.
Pattern matching
See?
has nothing
Yeah,
to do with.
pattern
A
matching.
switch. Yeah.
It has nothing to do with macros. I'm confused what the macros are doing.
I feel like most of the
Yeah.
languages I've seen, pattern matching is either part of the grammar of the language itself or implemented as a macro. I feel like it's not usually implemented as a function.
I don't understand how you implement it as a macro.
Yeah, speaking of the macro, recently I come across the Eclipse collection, and they claim that they have like a special container called the primitive container. For example, the int array list, which is basically it's like an array of integer. But unlike like Java container, so you basically store a array of objects instead of the primitive integer. So they use like a micro, actually. They use like a template string template engine to generate a lot of different array list for different primitives. So you can take a look at that for this file, and the suffix is stg. Actually, this stg is a string template engine or something. So so it's very interesting because you know, when you compile this when you build or compile this Eclipse collection library, you basically do something like C++ template instantiation for those like 8 different primitives except Boolean. And you can use it like a very compact data structure. And also because it's primitive, so I believe the performance should be way more efficient than like a Java's collection. And the reason I came up this because you talk about like a micro, and I still feel that micro is still have room for Java because sometimes you need to generate some kind of boilerplate code to get like a best performance.
I've been there even recently.
That's why you have a framework to generate bytecodes at runtime. What was one? Java Buddy, something.
Oh, there's a bunch of frameworks for doing bytecodes at runtime floating around. You're talking about though doing a template style thing. Like I did a non-blocking hash map long, and then I was doing these stupid TCDH queries, and I needed to have a version that had ints as the key instead of longs because I was having 100 million keys, and it had to fit in, you know, some amount of space. And so it was substantially faster to drop my key size from long to int. And there was a version of that for sparse bit sets where I had the same problem, but didn't have any payload. So I wanted to have a bunch of variations of, and it was all concurrently updated for efficiency across my 20 core machines. So I wanted to have a multi-thread concurrent algorithm that keyed on ints, keyed on longs, carried a value, didn't carry a value, and all versions in between. Hey, Theodore, see you. I get the problem.
The Hixindu was telling him bye.
Oh, okay. The other thing. Oh, he's gone. Fine. Thanks, then. Yeah, the AA. My theory is I'm going to do cloning, but maybe I should argue that people have to ask for it. Cloning under the hood of the primitive types for the different models of things, so you can guarantee your. So usually an array storage structure on the bottom is typed as what you want it to be typed as because of space and size concerns.
So if I want to make
So-
0.2 and 0.3 and
Yeah.
have some function that works on either 0.2 or 0.3, how do I tell you, no, I want you to actually generate 2 copies of this function that are optimized for these?
I don't have a way to think about that one right now because I'm not claiming I have object inlining. So your 0.2s and your 0.3s are structs that are not object inlined into an array. And so therefore you always have a layer of indirection, and the array just deals with an object pointer. It's the Java model, right? Now you can come along and claim 0.2 is small because I'm using byte wide points, or I'm using 2 byte points because it's just my screen on my monitor. And I want to have shorts, and I want to have a bajillion of them packed. And now I want a packed collection of 0.2s or a packed collection of 0.3s. And what's the right answer for that one? And I don't have in my head a clear and obvious solution. The thing that I'm leaning on is honestly doing the reverse and saying, I'll give you a freebie struct of arrays versus array of struct converter. So if you have a bajillion 0.2s, I'll let you say, declare them specially as a struct of arrays. So it'll be a 0.2 named array for the X and the name for the Y, and each of those array contents will be whatever. And it just is an exploratory thing, but I don't know.
That Java programming language has automatic conversion from structs to arrays and arrays to structs and vice versa. But he dropped that feature. I don't recall why he dropped it.
Okay.
He said it to reintroduce it later, maybe.
The other version is just do object inlining, or go to Swift and say some things are values and some things are by reference, and you can ask for by value or by reference. If you're by value, you can be object inlined. And then storage class matters because that's how I'm going to smash you when I object inline you. Yeah, there's another one from Matt. Thank you.
I almost want to think of that as optional, to be like, here is a namespace, it's keyed. Here is an index space, it's got consecutive numbers.
Right.
And if you want to, you can say, oh, by the way, this index space better be an array, or this namespace better be a struct.
No, that's not a bad API call to have support for somehow.
Because most of the time when I'm writing code, all I care about is this a namespace or is this an index space? And I don't really care what's under the hood, and let the compiler pick something reasonable.
Right.
And sometimes I want to be like, no, I actually need this thing laid out as a struct with the fields in this order because I'm like setting up parameters for some syscall.
Yeah, see, that one's more unusual. So let me back off here for a second. Let me back up here. What you said was, I have an index space, I have a namespace. It's really common to have structured arrays, array of structs. It's exactly what I have. I have a 2-dimensional space by index on one and by name on the other. And if I bring you an API that talks about that directly as that format, then the compiler under the hood can choose left or right according to what he wants. But you don't have a pile of 0.2s anymore. You have a 0.2 collection, and you give me the collection number and you give me the X or the Y. And then I'll fetch out or let you set or whatever the right API there is. And then
it reminds me a little bit of SQL. In SQL, I say, here's the structure of my table. And if I want to, I can add an index and say, no, like actually lay it out this way. But most of the time, I don't care.
Yeah. So you also said I have a forced layout on a struct, which in my mind, I don't see a use case for except in like various kinds of weird embedded systems where I'm overlaying the struct over hardware. There's a storage space mechanism where I want to say I have very dense storage of these structs. So I don't have one of them, I have a bajillion. Well, as soon as I have a bajillion, I'm in the 2-dimensional version. But I have singleton instances of a struct. Do you really care about the layout? Why do you care about the layout? You're doing foreign function interface, that's one issue.
I care about the layout because the struct layout is UDP packet.
No, okay, so that's either a foreign function or it goes to a hardware. You're doing a struct over a hardware layout.
Well, everything that is serialization or deserialization, that can be a lot. That can be a lot.
Those are, well, they're exciting for performance to get them correct, but they're a specific case. All right, I have to actually use the head, so carry on without me.
So Cameron, should we revisit the code evolution and hot code reloading topic?
Perhaps. I just posted a gist though for Aaron for the Python question.
Oh, a typo, a point to a point 3D. Yeah.
You're able to do that because your switch statement is built into the language.
Yeah. But so is Java's. I think the issue in Java is that there's no
In Java, there is no. Is there a case with
structure? Yeah.
Mm-hmm.
There's some limits to switch in Java.
Yeah. It cannot represent objects, I believe. It have to be.
Right. And they keep on carving out new exceptions. So I think you can switch on string. Actually, yeah, you just switch on the class simple name.
Can you switch as a part of the instance of to make the switch? The case is just instance of some class and blah, blah, blah.
You're working on adding something like that? I think that's one of the things Brian Getz is working on. Some sort of as part of the pattern matching. They're trying to add pattern matching. Project, what's it called? Project.
If I switch on an int in your language, are you going to help me know if I haven't covered all my cases?
Yeah.
So I can be like 0, do this, 1, do this, anything less than 2 to the 32, do this, anything 2 to the 32 plus 1 to 2 to the 64, do the last thing.
Yeah.
And if I like miss a number, it'll warn me and be like, hey, you covered all but one of the integers.
So with the switch expression, it's an error if you don't have a default. If it's just if it's a switch statement, you're not required to have all of them.
He means the switch to cover all the possible values, let's say for integer 2 to the 32. Yeah.
I mean, take a simpler example of Boolean. Right?
Yeah.
So you got, or byte, say you got bytes, so you got 0 to 255. In that case, if it's a switch expression, you have to cover all of them, or you have to have a default.
No, okay. You can omit the default if you prove that you have all the cases. Okay.
Right. And there's always an implicit default if you cover all the cases because of code evolution. So say you have an enumeration of colors, red, green, blue. Someone comes along later and adds yellow and orange, right? So when at the time you compiled, you only knew about 3 colors, and later you know about 5. So the code that was compiled.
Yeah, I kind of want that to just blow up on me when I link and be like, you've got switch statements that don't cover all the cases anymore.
Well, yeah, I mean, you can just, I mean, you have to have some reasonable default. The reasonable default we chose was that we blow up when a value is presented that was not
by implicit default, you mean like throw?
Yes. Yeah.
Hey,
okay, got it.
Well, and implicit default meaning some decision. There has to be a predictable decision. It's not a right versus a wrong answer. It's that unless you make a full copy of the library, you don't know which exact things changing would break binary compatibility. So, in a case of Boolean, it's always going to be false and true, right? But there are other enums that would change, or, other, sets of values whose count could change. So,
yes. The gender enome seems to keep getting larger.
I'll leave that at that.
That seems fair.
So,
Although I was
code
surprised
evolution?
when I had a piece of code that broke once because someone added a day of the week and I had an uncovered case.
They added a day of the week.
Yeah, they made it Sunday through Saturday or unknown day. And I was like, I was not expecting an 8th day of the week value.
Yeah.
So I've been listening to the Napoleon biography, and a lot of the dates they give are in the Republican time. So after the overthrow of the monarch, they went to a 10-day week, starting on the, I guess Bastille Day was day 0 or something, like, so they had their own calendar. It's very confusing.
10-day week. Republic time.
I mean, a 10-day week is easier on your brain than having megasecond long sprints.
It's easier than multiplying Roman literals. Of course.
And how many feet are
Just
in a
kidding.
mile? But I don't know.
That was one of my favorite bugs when we had a system that always crashed at exactly 2 to the 20th seconds of having been running. I was
Excellent.
just like, why does this thing always die exactly at the megasecond? Which is totally not obvious because that's just not a number you recognize.
Oh, yeah, right.
Like
Yeah.
it blows up at like 11 and a half days or whatever it is.
I've seen a bug that happened when a pre-allocated string for the date got overrun by exactly one byte, which exactly happens every other decade or something, and it's like October 31 and something else. So the day of the week has to land on a Wednesday, whatever the longest day of the week is. So it has to be the longest month name, the longest weekday name, and the 2-digit whatever. And somebody just didn't count digits and got off by 1. Every other.
Have you ever seen a system blow up because it was the 60th second? ISO time is 0 to 59, except for the leap second, which is considered 60.
Oh.
So if you have a transaction that happens during leap second, it can have a 60 in the seconds field. And that occasionally will make something blow up that wasn't parsing timestamps correctly.
I did fintech log files, and I just threw them at Jodatime, who handles all that shit.
I recently watched the video with that guy who manipulated the lottery numbers. Yeah.
My microwave, by the way, will take 99 seconds as a count of seconds to count down on.
Yeah.
So it doesn't blow up at 60.
Yeah.
Well, I want to ask a question. So we talked a lot about Rust and ownership and, all these ways of avoiding garbage collection. So what's wrong with garbage collection? Like, why does nobody want it?
Because it has a good and it has a bad, and depending on where you land, you want the one or the other. The bad things, it gives you non-deterministic GC times, which goes directly to the time to get a job done in a small scale, which turns into user experience because your web browser got slow because it stopped to do a GC pause at an inappropriate time. Your game got slow, drops frames because it's doing GC. You're doing fintech trades. You have.
I was going to say it's also a question of language too, because it's not the GC. So there are some people who just think GC is bad because they're ignorant. I mean, we're all ignorant of something. So
yeah, let's not go there right now.
But there are reasonable arguments against it in, say, C++. I mean, C++ or C, I mean, or Rust. I mean, they have concepts that they use as first principles in the design of the language. And, I think, so that link that Cliff shared at the start, that talks about some of them, but like, in Rust and in C++, they're often talking about, you only pay for things that you use, right? So that concept is fundamentally incompatible with, for the most part,
Yeah.
with the concept of garbage collection.
Yeah. GC is highly invasive because it crawls all stacks on all threads. Now, in your language C, in your language Java, in your language Perl, Python, whatever, crawl your own stack at a byte by byte sort of level, pointer by pointer level. There's no one in any language that does that by default. So immediately GC brings in this concept that I'm going to view your stack itself as a pile of bytes. I'm going to view all your pointers as a pile of bytes, and I'm going to manipulate them all. And that requires sort of deep understanding of the runtime layout of your stack and of access to all kinds of weird shit. So it has this, thing that it does outside all their scopes. It's highly invasive. You either have a GC or you do not. You can't, there's no halfway in between. And if you paid for a GC, you can't unpay for it. You have to have it running anyhow. So there's another cost actually that I talk about all the time, and that's bump pointer allocation is what GCs usually do. Guaranteed give you data that you've never been in your caches since the last GC cycle. 100% guaranteed it's a full cache miss. Furthermore, if you're pounding through them, you're allocating at a high rate, then the things that you use for a while and then die are dead in your cache, but the hardware doesn't know this. So it writes them out even though they're dead. And you burn bandwidth once to bring in a piece of memory that's typically not, that you're going to stomp to zeros. Even a modern x86 with 30, 40 years of Java behind it still does this, has no way to shortcut it. And then you wrote out the dead object when you're done, the dead memory space when you're done anyhow. So you burn double bandwidth. And if you look at a malloc free cycle, if you have a high volume throughput that you're processing large amount of data on, and you use malloc and free, the malloc and free goes right on a free list and comes right back off, and you recycle the same memory. That memory has the same virtual address space, same physical address space. It camps out in your L1 cache. So you malloc an object, it's just a few L1 cache hit pointers. It's all L1 cache memory. You manipulate it. When you're done, you freed it. A little bit later, you allocate it again, all L1 cache hits.
Plus, if you're working in C++, you're going to have your own custom allocators for various types. So if you have you have to allocate 1 million tiny little objects, you're generally going to override the allocator for that. And they're going to be coming from the same chunk of memory.
Yeah, you play a lot of memory shortcut games, which these turn into large performance numbers.
Yeah.
So the GC versus not the GC version I'm talking about, I can write plain old Java code where I hand malloc and free versus use the GC that give me 5x differences in speed, 5-fold, not 5%, 5-fold differences in speed, processing large log files. So GC has incredible convenience, huge class of bugs go away. Flip side, irregular pause times leading to poor experience if you need to have reliable low latency. It leads to high bandwidth consumption, which if you got enough, you don't care. But if you're out of bandwidth, you care. And what was well, in the games of the C world, they just have a different paradigm. They think about these problems, and that's how they sort it.
I would say that there are also important non-performance reasons which make the trade-off complicated. 2, design complexity and interoperability. So design complexity in this case means GC is a glorified global variable. Whenever you have a GC language, you knew is usually one global allocator. And the object graph that this results in, put yourself in the shoes of application developer who's working on a code that is not a new code and you just entered your first week. You usually have to start by reverse engineering the created object graph of the application with all of the implicit connections in your head. And only after you are done with this dynamic analysis you had to do it yourself, you can actually begin to work on the application. So there is an advantage with localizing the memory allocation and deallocation. And I think GC languages push you toward globalizing this in practice. It doesn't have to be this way, but just in practice, it happens to be this way so far.
And the flip side of that, to be fair, is that non-GC languages generally don't allow that type of processing, so no applications are written in C++.
Yeah.
Because it's simply impossible to have anything other than hierarchical scope in C++. And when I say impossible, what I mean is outside of a few developers in the world, I wouldn't trust the code on a production machine.
Yeah, challenging to maintain correctness of.
Challenging to maintain. So challenging that Cameron's right. I've done a lot of looking at these things, and there's like 100 times as many large-scale giant applications written in Java than in C++. The count of million-line C++ programs, there's hundreds in the world. Count of million-line Java programs in the world? Oh my God.
Of course, one could argue whether the large scale and the large number of lines of code is a good thing.
No, it's not a good thing, but it's a question of alternatives. These systems could not be built in C++.
Right. That's
because there's only 100 developers in the world who are capable of doing so.
Maintaining
and none of them want to be writing your website for you.
Yeah, I mean, there are applications, but I think that in many of those applications, it's not Java that is the choice, but rather Python or PHP.
You don't get
you can have thousands PHP developers to one Java developer, and they have all of the same pros and cons that you just mentioned relative to C++. They are also cheaper.
I claim you don't get million-line Python programs because the type unsafety makes it impossible.
Yeah.
Well, there are million-line Python programs.
Yep. In ideal world, you shouldn't, but we don't live in.
No, I'm not saying there's none. I'm just saying that you look at the count of million-line Python programs. I bet you it's less than the count of million-line C programs, which is far less than the count of million-line Java programs.
A large untyped programs.
And then there's the performance.
Oh.
Yeah. Well, yeah, we talked about right.
I imagine Python doesn't compare with C2 in terms of performance, right?
No, but this is a thing that they're happy with. We've done this math many times. I talked to them repeatedly, and the answer came back, we don't fucking care for a proper JIT. So you go look on why is a high quality JITted Python like PyPy? Why is PyPy not the next generation Python? Because PyPy says, here's the changes we make to Python so you can reasonably JIT it. And the Python community said, no, we'll be 10x slower. We don't care.
And they have a good FFI with C++. And they write the
we'll just call out the C++ and that's it. So
No.
they have this funny bifurcated model. They have something well-defined, tightly specified. I'm going to write it in C code to get my speed out. And it's going to be an ML algorithm. Or it's going to be the core chunk of a web server that does the actual serving or whatever. And then I'm going to write my application control logic in Python. And as long as you can have modeled your systems that way, it makes sense.
I just want to be clear when you say application control, that's the self-modifying types changing on the fly code.
I'm not going to defend Python.
Well, no, but that's why they can't use PyPy.
There's a bunch of reasons. Go read the webpage. They have a discussion. Here's the things we would have to do. And some of them were break the global interpreter lock, which would allow parallelism, which would allow a whole lot of C code to break, which because it's implicitly assuming there's no parallelism. Some of it is, we screw around with types, and so you have to not screw around with types. Most Python code does not. Some Python code does. The Python community said, we like to screw with types, even if we don't do it very often. Okay, done.
And that's the same reason, by the way, it's the same reason that Ruby can't perform either. I mean, Ruby and Python have the same dynamic type system.
Yeah, fine. I mean, the JavaScript guys paid like giant engineering dollars to get reasonably close, right? We pile on effort after effort after effort, and you do all the profiling, and you discover that 99% of the time the types are monomorphic and don't ever change, and we'll just compile it that way. And if you change it occasionally, you fall out, and you have full of tests to verify you didn't actually change your types. And that's why we're not quite as fast as Java, but we're close.
But that's the difference, that the reason that JavaScript was optimized wasn't because anyone liked JavaScript.
Oh, no.
It's because Google couldn't succeed as a business unless they optimized JavaScript.
Right. Your web pages had to be pleasant enough that you're happy to shop on Amazon for hours on end, and Google got all those ad dollars. Ding. Yeah.
And also, I don't think JavaScript can pull off the FFI trick that Python does.
No, it doesn't.
Calling the C libraries, essentially.
No,
I mean, they're very much trying that with WebAssembly.
Now, yes, today. but you had to create WebAssembly first.
Well, what
Yeah.
about Node.js, guys?
Node.js is without the browser doing the display, but it's a JavaScript engine.
Well, what I'm saying is it has great FFI to C bindings. I mean, it's a great way to administer like a Unix system. You can make any, I mean,
Bye, Charlie.
Yeah. So, I mean,
But
JavaScript certainly is capable of FFI with low-level systems, maybe not in the web browser environment, but there's nothing in the language that prevents you from building.
Yeah. No, the web browser was there for security. The no FFI is there for security, and the web browser provides a huge FFI interface already. Like, if you can't get it out of the web browser, you're doing something weird.
But the other interesting aspect of that, Cole, is that Node.js was created after and as a result of Google creating V8.
Oh, was it?
Yeah, that was the order. So they created V8. People are like, wow, JavaScript doesn't have to suck performance-wise.
Right.
And then Node.js popped into existence.
I want to claim myself to the Node.js guys very early on, but now I'm not sure what order what came first. I know they were struggling a little bit. Like, it's cool and the web browsers everywhere, but
the showstopper is that it's a single threaded. The showstopper is that it's a single threaded still.
Node.js brings in the browser does too. Brings in parallel in practice without any cross-thread communication. Node.js brings in some cross-thread things like shareable caches, which is one of the main things that they do for parallel things. There's no real parallelism in the model. You're right. Single-threaded model, and the browser brings in obviously parallelism in every tab.
I want to say that Node.js experimented, and I don't know how far it went, but so V8 supports a worker model, which in the browser is only a second thread, so a total of 2 threads. What it allows you to do is take a DOM and make a copy of the DOM that's passed to another thread running JavaScript, which is called a worker. And I know V8 was trying to leverage that. This is like 10 years ago, so you can see how well I kept up.
One other thing I believe it does, it's streaming, interpreting JavaScript as it comes along, but you have to have multiple libraries, and it can offload that from the main thread and reinterpret it in that background thread. I believe it does parsing this way to make parsing faster.
Right. Oh, so everybody, yeah, that makes sense. Okay, fine.
What is Node's concurrent hash map?
I want to say that Node.js, one of the things they have is some sort of concurrent hash map or multi-threaded safe hash map, so that a Node.js server can share like JDBC requests across the client server she's doing. Like, Node.js is running essentially JavaScript executing web requests, right? And it's an internal web request for whatever.
Yeah, frankly, I think the model of here's a work queue and any work that is generated gets thrown on the same queue for the same thread seems fine to me, as long as you have some kind of concurrent hash map that lets them share a cache.
And I have stumbled across a project that tries to convert JavaScript to native executable.
Next.js. Okay.
Yeah.
Yeah.
It turns JavaScript into a binary.
I definitely did Node.js development. I used it for development. I was doing a app on a phone, and if I wanted to test, I wanted to run without having to stare at the phone or whatever. I did a bunch of things where you just throw it in a Node.js server that was running behind your back. And then you get in the development cycle, and Node.js was running in the background of the development cycle and all that kind of shit. It was exceptionally complicated without any good reason.
But it won't succeed because it's
no JavaScript's God mode. One language.
Yeah. Yeah, hell of a slogan.
Fine.
I still feel like JavaScript basically won because it had the ability to load code at runtime.
Yeah.
No.
You go to a
It's
website,
because
you get a program, and it's halfway decent security model.
I believe they won because it's a web language. And
No, but
you-
what was it with the web language? It was a web language.
Wait.
I think Aaron's right. It became the
Yeah,
web.
why is the web language not Java?
Yeah. Boy, Sun tried hard
Hmm.
to make it Java.
Oh, it's applets. Yeah. Okay.
Yeah,
Yeah.
right.
Hmm.
And it was because, and Microsoft tried hard too. And the answer is JavaScript could load code. I think you're
Yeah,
totally
but keep in mind that JavaScript came from Netscape.
Netscape, yeah.
I mean, and
Yeah.
Java got to carve out a piece of the screen inside the HTML where it could do Java things. But what JavaScript was designed to do was actually to manipulate the DOM in a way that the
Yeah.
browser would know when to redraw. And that's a pretty fundamental, from an interactivity point of view, it's hard to beat.
Right.
And
But
I think
that was
at the time it was even called LiveScript, if I remember correctly. It wasn't even called JavaScript until 96.
Yeah.
Ooh, oh really?
I do like the original memo for LiveScript where he's like, I'm porting Scheme to the browser.
I missed that one. Wow. Yeah, it got close. I mean, it's a nice little
It
functional.
was 2 weeks. It was a 2-week project from start to ship.
Yeah, it was a little tiny. If you don't do typing and you don't do any code gen, you just do coding, you can go pretty fast on this stuff.
That's my problem with JavaScript. It has no types. Yeah.
It has the best design that you could get out of a language that was designed and implemented inside of 2 weeks.
Yeah, I can agree.
Yeah, if someone told me you have to design a new language for a production environment in 2 weeks, porting Scheme is not a bad idea.
Not a bad way to go. Right. That's why I'm with them. All right, Alan, just so you know, we get to see your thumb and point blank here. You must be on your phone.
iPad, maybe?
Yeah, I'm on my phone. I'm not very good at this. So,
all good. And Nectar, cyclic references, leak memory. Yeah, garbage collection.
So, yeah, I don't know. So I guess, I mean, the main question I have is if it's possible to combine garbage collection and malloc free. And like, you know, like I think it is. It's a very simple model. You have
you get all the issues of having a garbage collector floating around. Separately, you can do malloc and free if you just tell the GC this is not yours, don't touch it.
Yeah. As long as you keep them separate, there is no issue.
And people have tried that.
Memory areas that copy between them is what I'm thinking.
Yeah. My main advice there was make sure one of them's on top. Either you live in GC land and you write a slab allocator that allocates large chunks of memory in GC land, and then you do whatever inside your resource pool. Or you have unique pointer and you have a little garbage collected thing inside your program. But C++ is very clear that malloc and free is the thing that's on top and shared pointer is implemented within it. And in Java land, it's like garbage collection is a thing on top and resource pools is just something that's implemented within it.
Yeah, somebody's right.
Well, I think what's on top is the page allocator. I mean, you go to the OS, you say, give me a chunk of memory, it's going to give you a page, right? That's what's on top.
I mean, decoupling the operation from the allocation, I think it's also, this is a style in C. I'm not touching C++, but in C, good style is to have your interface take a pointer to the buffer containing the data you're operating on. And it's a major faux pas to have a malloc called inside a function you are calling from the library. And I think that's one of the good points where it decouples this hidden heap global allocator state from whatever the operation library is going to accomplish. Because it's not a domain-specific operation. If you're calling a numerical library, you probably don't expect the numerical library to manage memory for you. And in this way, it kind of makes sense. So it's purely a design issue, I would say.
If you have a GC, you have the invasiveness of a GC, including I can allocate anywhere in libraries and it goes to the main GC heap, and then the lifetime's managed by the GC and all that.
Well, that's shared mutable global state that we should be all afraid of.
I mean, maybe yes and maybe no.
Tongue in cheek.
like to some extent, the reason REPLs work well for debugging your stuff is because there is shared mutable global state. And you can be like, I need to replace this function with a new version of this function that also logs a piece of information. And I would like to do it at runtime because I'm debugging something that I will never recreate.
Well, yes and no. I'm not sure if you recall this paper. It was critique of Jupyter notebooks user experience from developers' point of view. And what the point made was that Jupyter notebooks accumulate this global state. So in the first 5 minutes when you are beginning to work on this, it feels interactive, fun, and easy. But after those initial 5 minutes, you have accumulated this global state and it's hell to debug and hell to maintain. So I think there are trade-offs. There are different slopes of different curves here.
Yep, REPL is perfectly good for 5 minutes or less.
And then you should kill it and start again. Yeah, our folks worked really hard to have our scripting environment, which basically it's a workflow for moving from a REPL development into a steady state, repeatable process.
Yeah, and I think, by the way, you could look at Smalltalk as just being a giant REPL that never goes away.
Yes, yes.
And I think, I would probably, there
I
are
kind of
a few
I kind
friends
of
that would
disagree.
disagree, but it's probably one of the reasons why it didn't
Take off.
why it struggled to stay alive. Yeah.
Yeah.
I could argue that a Linux server is a REPL with state that just doesn't go away.
It is, yes.
No, I disagree. I think a Linux server is ephemeral unless you work really hard to make it non-ephemeral.
Really? So I've certainly done Linux server management games, and they kept fucking accumulating state, and periodically it got too confused and you wanted to put all the important state somewhere, wipe the machine clean and reload all important state. Otherwise you kept accumulating crap. And that was, getting a server that would run your continuous integration without gradually accumulating logs and temps until you drowned in them was an issue.
Yeah, that's a reasonable point. What I was thinking was how many times I have seen, I'm not admitting to doing it myself, but I've seen that the solution for Linux administration is a reboot. An automated reboot is what
an
I'm.
automated reboot. Yeah, I'm actually talking about a format your hard drive. Oh, pets versus.
Yeah, like
Yeah.
what
Rebooting,
with Windows
rebooting
Surface
is your
once a
best
month.
Matt,
best strategy.
This pets
Yeah.
versus cattle is a well-known analogy that maybe you shouldn't treat your server as a pet that you spend a lot of time on and maintain, but rather just one of many cattle you have.
Yeah.
And it's maybe something you just restart in the cloud. You don't even know what is what's the state.
Restarting is the best possible strategy, at least to me. Even when they're doing the computers wasn't so much advanced. It's in the rockets. There has a specific rule that you have to, if there are multiple components, you have to have the ability to restart it, to reset it to a known state in order to proceed it back.
I would say that's the fundamental tension between developers and operators.
Yeah.
Is the operator's credo is turn it off and turn it back on again so that we get up and running as quickly as possible. And the developer is like, do not destroy the state. I need that state to debug the problem.
Yeah.
Do not agree that you accumulating state in time is the problem. The problem is you don't have a good way to manage it, and types are a good way to manage it, but it becomes a whole lot of program and infrastructure you have to support. But
it's not just types when you talk about a server now. It's files, it's processes, it's shit that keeps accumulating on the server.
So a type can get much more precise about things, and the functions with the types can get you almost 90% of the way, and that is an entry point for a code evolution.
Well, that's what I'm talking about. This would not be a Linux server then. This would be some pure functional language as the entire machine server.
Okay.
Haskell server?
Yeah. But I'm only ever using it as a like a Linux server, but it's a Haskell server instead. Which of course Amazon will sell me one of those, and then they'll just reboot themselves. But they have the whole cattle thing figured out, pets versus cattle thing figured out. I'm part of the cattle.
I want that types. I don't want mutable state, mutable bytes that point to some obscure
Nah,
space.
you want some.
I want that. I want that types. You want that types. We all want that types
You
because
want
it's easier.
some mutable state. You are
Okay.
a giant wad of mutable state. You learn,
Okay.
you go forward, you grow, you personally, and therefore
Okay.
everything around you is also part of your mutable state.
Hold that
You
thought.
want some mutable
Hold that thought. Okay, the universe itself goes digital. If you have an analog signal, you have it analog signal, and it has its properties. It has its downsides that it decays with the further we'll go to the sources. But if you have a digital signal, you have the ability to send it back across the much larger space, time, not time but space, and you reconstruct it back again. And this is digital. This is a function state by state.
No, it's not how it works.
Okay.
You get that digital signal, you want to send it somewhere, it goes analog. It gets there, it gets converted back to digital. It's analog all the way.
We'll see. We'll see.
I will say that quantum has a state change. Quantum affects a pure state change, and then I get state changes in like safe points at the higher level. And the x86 hardware does state changes where you think it's running instructions one at a time, but it's actually running them bunches at a time. It only takes interrupts every so many instructions because that's how it's breaking them apart and parsing them or whatever. It's also got a safe point like effect that's not per instruction, it's per group of instructions. So there is this notion of I run from a known machine architected state to another one, and I don't let you see what's in between. But when you get to the size of Linux servers, that's not available to you unless you have very carefully arranged my state. Like my state is I run CI testing, day in, day out until I hit the reset, the reboot button. And then I allow you to see the state again at the reboot points. In between, I can't let you look because it's a fucking mess.
Okay, how about this? We broke this state to a known state, so we digitalize it to a known steps, and we replace it known steps with a new type of known steps. This is a continuous.
You have to be able to specify the strong types, architectural meaning at each of those breakpoints.
Yes.
Because the goal of like hot swap is to swap at a bytecode boundary where the programmer says everything else is all type safe.
Correct.
But does it actually have the same meaning? I don't care. I'm allowed
the problem, this is maintainable as still as you maintain the structure of digitalized things. You can periodically slap with newer versions of this function as long as it fulfills these types. Okay. The problem becomes if you have to break this state, if you have to break the type because you need to somehow you have a newer version of this and you have different types, and there is your problem.
That was the goal, Matt. That was the goal. Sorry.
Okay. So we for it along. So these problems, types versus state versus analog versus digital, pops up everywhere, and because it's the fundamental problem everywhere. Right. I believe so.
I'm not prepared to handle it, to solve it all right now, though. All right, it's time for me to break and go get lunch.
Okay. Next time. We'll continue next time.
Backwards compatibility for all time now, Intel.
For all time, always.
Yeah.
Lucky.
Oh, another link. God, 1,000 links today. I will come back around to that. Very entertaining. This was one of the better ones. Yeah, fun reading, 1,000 things to read. And I mean, real life problems are still reaching out to grab me. I have to go DL, so I don't want to get to this stuff. Oh, bye.
Cool. Bye.
Bye.
Cliff.
Bye.